Good morning, good afternoon, good evening, good middle of the night, I guess, to some of you around the world tuning into our eCognition webinar today. My name is Keith Peterson. I am the product manager for our Trimble eCognition software. And I'm really excited today because, well, we have the release already out, went out on Thursday last week. Everything seemed to go very smoothly. And now I get to tell you all about what's inside of this new version of eCognition, eCognition Suite 10.2. Okay, before I jump into the meat of the webinar, let's just go over some of the ground rules. Yes, everybody is in a listen-only mode. That's intentional. If you have a question for me during the webinar, please use the question dialog and submit it. Please start submitting the questions as soon as they come to you, because we'll be fielding some of the questions during the webinar, and of course we'll have a bit of a Q&A session afterwards, but please get those questions the earliest or the earlier the better to us, and we'll answer them, okay? Other thing to clarify right off is, yes, this webinar is being recorded. We record all of our webinars and it will be made available to you afterwards. We also put all of our eCognition webinars into eCognition TV. That is our YouTube channel, and there you can watch them as much as you like in case you miss something today. I hope everybody can hear me well and see my screen coming to you from a beautiful, freshly snow-covered Vorarlberg, Austria. Wonderful to have the snow on us today. And yeah, let's get right into this thing. So first of all, we might have some eCognition newbies out there. That's great. Welcome to our eCognition webinar series. Maybe we'll just clarify, what is eCognition? You see it down there in below in 2 words: feature extraction. eCognition is about feature extraction. But the general idea is automating feature extraction. And we want to take these representations of the real world that we have, be they maybe image data, your standard aerial satellite drone image data. Maybe you have rasterized elevation data, DSM, DTM, something like that. But you can also bring in other types of data sets that represent our real world. And what we are doing within eCognition is we are automating this image analysis workflow. How do we interpret what's in our image data, or not only image data, point cloud data as well? What is in that geospatial data, and transform geospatial data into valuable information, okay? That is my experience. The biggest hurdle for people is coming maybe from a GIS perspective. You're used to dealing with information already. It's just how you visualize that information. But here within eCognition, we're actually creating that information. And that takes a bit of a different mindset to get into, but eCognition provides you a number of different interactive tools to do this. One of the most important aspects of eCognition, and for those of you that know me, probably say, oh, you sound like a broken record, but this, I have to get back to it every time, is data fusion. And eCognition has an incredible, powerful set of tools within it that allow you to combine those different types of geospatial data. Could be the raster of the image data, as you see up on the top. Could be existing vector data, so maybe your shape files of certain parcels or forest boundaries that come from another data source. You can also bring in point cloud data, okay? Only caveat there is LAS, LAZ files. It doesn't matter from what device, as long as it's LAZ or LAS. We can bring that point cloud data into eCognition, and we can read the different fields, say those point cloud fields within that data. But the biggest and most powerful aspect is that all 3 of these data types can be seamlessly combined with one another within a single project. That means that the characteristics of my image can communicate with the characteristics of my shapefile, or the characteristics, I should say, and or the characteristics of my point cloud layer, all right? And we can combine all those different characteristics to describe, for instance, a class. So what is building? Well, if we think of that as a very simple example, a building is. We'll look at this image here. It's got a very bright roof in this image. Well, that's great from an image perspective. You can use brightness characteristics. You could use an NDVI. It's going to have a negative NDVI value. But we can also say typical about buildings is the fact that they're elevated, and we have that type of information in our point cloud. So we can take that point cloud elevation values to also combine with the raster values to describe a building versus, say, a forest area where we also have elevated objects and trees. All right, that's data fusion in a nutshell. Another thing that I'm very proud of, particularly because I've been building it up over my product management tenure here with eCognition, is method fusion. All right, we have many different ways that you can actually classify or describe those image objects within eCognition. You can use knowledge base, where I, as an expert, tell the computer this is a forest based on these characteristics, these thresholds. You can also use unsupervised classification, where you say, well, computer, here, split the image into 7 classes, and it will go find the characteristics and split those into those 7 classes. You can also use supervised classification, and this is an example we're going to look at in our demonstration project today, where you can give the computer a set of classes, a set of characteristics, and say, well, using these characteristics, these features, classify my image. Right. We also have computer vision. So this comes in the form of template matching within eCognition. And finally, last but not least, deep learning. Okay, so you can train and apply deep learning models within eCognition, and we'll get into some of the more technical aspects of deep learning because we did a lot on that in this release as we go on. But again, the most important aspect, at least from my perspective, is that you're not locked into any one of these classification schemes or methods within the software. You can combine them all or a few within one project workflow. So I could start out using a deep learning based classifier, get a sort of rough approximation of my classes, and from there start to apply knowledge-based rules, so some of those traditional OBIA rules, to that deep learning result, and really get a much better looking result in the end. All right, that's one very popular combination if we look at much of today's recent literature. All right, so we had data fusion and method fusion. All right. Finally, what are the different products that compose this eCognition suite? We'll start with the 2 major ones. So first of all, developer. That's really the heart of eCognition. That's our development platform. You create these rule sets. A rule set is that set of algorithms or rules that make up the automated workflow. All right. Very powerful in combination with eCognition Server, which opens up the world of batch processing to you. And finally, we have eCognition Architect. This allows you to put, say, a graphical user interface around that rule set and put the power of eCognition, say, into the hands of maybe the non-developer, someone who should be executing and creating results, but not bogged down with actually developing the automated workflows. And I don't know if Giles is listening today. Again, I always say hello. I'll see you soon. I'll be in the beautiful state of Vermont next week. But Giles really, he summed it up well when he talked about eCognition, really saying, what I used to love about eCognition was that it enabled us to bring together point cloud vector and raster data. So that's that element of data fusion I mentioned, without all the pesky transformations. Again, drag and drop those data sets in the eCognition, and they're all there and you're ready to communicate with one another. Went on to say, what I love about it now is how it gives us access to multiple feature extraction approaches. So that is this method fusion aspect that I was talking about. And then again, AI, in Giles' opinion, is not the future, but AI combined with existing approaches is. And I think that's a great way to sum up how we have taken our development approach, bringing in AI technology, particularly deep learning, is saying not putting all our eggs in one basket on deep learning, but bringing in deep learning as a very powerful method to describe and classify image objects, but it's just part of the eCognition toolbox, and when combined with the OBIA tools, it's just a 1-2 punch, unbeatable, and makes us essentially a market leader in feature extraction. So now the moment you've all been waiting for, what is new in eCognition? We have a lot of great new developments. Like I said, we brought out version 10.2 on December 2nd, so just last week, hot off the press. It's available on our website, so if you go to www.ecognition.com, you'll see the big tab on the top of the website, download current version. Go there, you'll get access to eCognition 10.2. So if you haven't done so yet, recommend doing it this week and really start to familiarize yourself. Before we get there, just a bit of a recap. Where are we on the version 10 journey? So we introduced version 10 back in 2020, came out with a few, say, minor patch releases, maintenance releases along the way, introduced 10.1 back in May of this year. And ever since then, really dove deep into 10.2, and that gets us to where we are here at the end of the year, closing out the year with a bang, and bringing you a really nice, powerful piece of software. So if you're coming from a version 10, you skipped 10.1, no problem. We'll get you up to speed. Most important thing is to get you working with 10.2 as soon as possible. So what did we do in 10.2 here? Some highlights. Again, the highlights from my perspective. First of all, deep learning for native point clouds. This is something completely new. We've introduced some algorithms for the classification of point clouds based on deep learning algorithms. These deep learning algorithms, or our deep learning models, I should say, in the background, were trained on native point clouds. So we're not doing any type of rasterized sample collection here. These samples are native point cloud based, giving you a much stronger representation or a much stronger and improved classification result for these native point clouds. This will be one of the examples we look at. I'll get into it a little bit more later. Another aspect of deep learning, like I said, we've brought a lot in the AI, and we're not banking on it, but we are investing quite a bit in integrating deep learning technology into the other workings of eCognition. Is we've expanded the integration of deep learning models within eCognition. So up to now, with 10 and 10.1, you've been able to use this TensorFlow save model format only for semantic models. So that was pretty limited at what type of semantic models were available out there. So with version 10.2, we're again knocking down some walls, and we've opened this up to support third-party instance segmentation models, as well as object detection models. So the majority of a number of deep learning models that are available out there on the web, maybe from TF Hub or other sources, they're going to be in that object detection or instance segmentation approaches. Why? Because we started creating those models earlier, and as deep learning became popular. So you can integrate those models into eCognition. We can read these external models, given that they have the right formatting. Again, it's this TF save model format, and you can apply them directly within eCognition, okay? That is this new algorithm called apply instance segmentation. Very, very nice algorithm to use. We've also taken a look at accuracy assessment. We had some old tools within eCognition. The accuracy assessment tool available from the toolbar wasn't maybe the most modern or user-friendly format. We've reworked, really overhauled that tool itself, and we've also added a number of algorithms that allow you to completely automate accuracy calculations and the whole process of accuracy assessment within eCognition via the rule set. And that will be one of the examples we look at shortly. We've also beefed up some of our native vector algorithms. So really taking a look at vector linearization tools to improve the extraction of linear objects within eCognition. In addition, we also saw that the way we were handling particularly large attribute tables, was not very fast, so we really gave those a workover, at least from the handling perspective, and you'll see a nice performance boost when working in attribute tables within eCognition. And last but certainly not least, we listen to you, our users, and we're always working to improve usability within the software. So we introduced in our new community, there's a great wish list area. Can only encourage you, put your wishes down there, and we do our darndest to fulfill those. So this go round, just to name a few, we looked at layer alias handling. How can we improve and make that easier? I think we did a pretty decent job at it, given the complexity that happens behind the scenes with layer aliases. Also looked at file navigation. We saw that we had a number of different types of menus still in the software, so we streamlined that file navigation menu for you. Feature selection, I'll show you some of this firsthand in the demonstration, but now it's possible when you're working with features and you want to display them, easy drag and drop to add or remove features within the windows in eCognition. Level toggling is back, so for those of you that put that wish known to us, you can now go and toggle between different image object levels again very quickly. And also one of my personal favorites, took us a while to get here, but it was a zoom to layer, so you can zoom to the extents of any type of layer within eCognition, whether it's raster, point cloud, or vector, okay? And ... there are a number of other improvements that went in. All the details you will find in our release notes, as always. Again, you can find those release notes on the website as well and within the software, and you'll get a complete overview of new features as well as bug fixes that we took on here. So in summary, yeah, version 10.2, again, summary from my side, we're really delivering you cutting edge technology. I think we've always done that in my opinion, but really pushing the bounds here now and bringing on deep learning with native point clouds and other third-party deep learning models to help you get that leg up on the competition, all right? Some of the other packages out there don't do this or don't do it nearly as well as we do. You can leverage deep learning on native point clouds. Again, this is groundbreaking. It saves you unneeded conversion times and improves the classification results in the end. That's what our internal studies showed was, compared to our earlier deep learning models, or excuse me, our point cloud classification models that we were using, this new deep learning approach gave us a much more accurate classification result. Fully integrated and automated accuracy assessment. This just makes the general project workflows much easier. If I think about my project work with eCognition, going and doing that accuracy assessment outside the software, doing all the exports, creating Excel tables or going back into attribute tables in GIS, for example, that can all be done and calculated very nicely and visualized within the software. And then of course, building out the support of third-party deep learning model support, that's something that's just going to be growing. There's a growing number of deep learning models available out there, and we're going to do our best to keep up with that growth and provide you the tools to input those and really get a direct OBIA output as quickly as possible. So those in my mind, that's the summary of what we've done here in 10.2. And that brings us to a software demonstration. But I think before I get into the demonstration, Christian, are there any questions that have come up so far?
Hey Keith, yeah, there is already a question concerning the external deep learning models. And here's a question, is it possible to retrain an external model, that the user just load the model and train it again with new samples in eCognition? Or is it just the trained model that the people can use?
Excellent question. And I guess I didn't mention that, or I flew over that point when I introduced it. So these third-party models that we support, they are pre-trained models. So you can bring in that pre-trained model and you can apply it with an eCognition. It is not yet possible to bring in an untrained model and train it with an eCognition, but you can completely build and train your model based on previous eCognition deep learning tools. Those are still all available within the software. And I should also mention on that note, it's not yet possible to bring in a pre-trained model and train it further with an eCognition, okay? That pre-trained model utilizes the training samples that it was initially trained on. That is also another aspect, say a topic for another day. A future version is to look at that side of it.
Hey, cool. Heath, thanks. And another question in this context is an eCognition server license required to apply the models?
No, absolutely not. eCognition server is only needed if you want to, say, apply those models in batch. So if you said, I have 1,000 images, I want to apply the same model to each of these 1,000 each of these 1,000 images without having to click 1,000 times. That's where server definitely has its advantages. But no, you have no requirement for eCognition server here. What you will want to consider is using GPU. Obviously, with the GPU processing, you're much better off than with the, say, more traditional CPU processing at this point.
Okay, thank you, Keith. There are several other questions, but they are related to point cloud handling, and we will discuss this later.
Okay.
Please go for it.
Very good. Then let's jump right into a demo. Like I said, I've set up 2 demonstration projects here today. The first one, well, they're going to look at these new automated accuracy assessment tools within eCognition. And then in the second one, we'll look at this deep learning based point cloud classification. That's, like I said, it's a new algorithm, a prototype algorithm. I'll also mention that as well. But we'll take a look at what's doable there. All right, just exit the presentation and jump into the software. So I hope everybody can see my screen. I apologize if it looks a little small. I might be able to increase the size of the buttons here. Just a minute. Oh, it's large. Maybe that makes it a bit easier. Okay. So I have an eCognition project here, obviously, satellite imagery coming from Yokosuka, Japan, an oldie but goldie image from our eCognition archive, but it gets the point across. I have already created image objects, so you see here that I've executed a multi-resolution segmentation, and I can click on these image objects as well. All right, so I'm getting ready to train and apply a supervised classification. So the first thing I need to do is create my image objects. I did that ahead of time because as you can see here, it just took 2.5 minutes to execute, and I didn't want to take that time from the webinar. So next, I'm going to calculate several additional layers here, one for my NDVI, and the next one will be for my NDWI. All right, because I have that input data here. You see once I calculate those, they become available here in our view settings dialog. You also see that for anybody who might be new to eCognition 10, coming from version 9 or earlier, that the visualization of image object levels is completely new, very GIS oriented now. You can come in, turn those off, control the visualization, the fill, everything right from the view setting dialog here. You'll also notice that I have 2 vector layers preloaded to my project. One is called ground truth, and I can just turn that off. That's a point vector layer. So you can see this is maybe representing some GPS ground truth data that I collected for the project, or my validation data set, if you will. We will need this later. And the second one is training sample layer. So for any of you that are used to eCognition, you'll see, oh, those look like image objects. Yes, I created my training samples within eCognition ahead of time and just save this as a vector layer. But these are my training samples. They represent the different classes here: forest, grass, urban, and water. So just keeping it simple for demonstration purposes. The next thing I want to do is then train my classifier based on my training sample information, okay? So we'll open the next algorithm. This is going to convert my thematic objects to sample objects, okay? So this is a new algorithm. It also we'll go into more depth on it in the accuracy assessment. So something that we developed in the automated accuracy assessment workflow, but you can also utilize it very nicely to convert directly from thematic or from vector layer to sample objects without having to do some annoying conversions that you were required in previous versions, okay? So I'm simply going to convert. I just specify which thematic layer contains my sample. So in this case, it's training samples. And if I am going to do this based on a certain attribute within that file, which class name attribute do I want to use? So essentially, which attribute contains the class name? In this case, not very creative. It's class name, obviously. All right. And the overlap requirement, this is specific for whether I'm using polygons as the layer. Here you get a little tip. So this will just select how the class for an image object, if we have overlapping thematic objects, is selected. Again, if the overlap requirement is not met, excuse me, no sample will be created. So that is something to consider here. You have two options: class with max overlap or class with max overlap and a threshold. So you can combine the overlap with a specific threshold. All right, we'll just use the overlap, execute this. Should run fairly quickly here. And then this is now merely converting those sample, those vector objects that I had loaded to a sample object. Now, if you want to see what those look like, first, it doesn't look like anything happened. That's because we're still in this classification view here. So if we come up and simply click on the drop-down arrow, I can now select to view my samples. And of course, we can zoom in, take a look at some of these. So I see I have some water samples here. Remember, the color for the sample object will also correspond to the color defined in the class hierarchy. So I have some objects for water. I see a few here for various, say, urban structures. All right. So great. Now I have my my sample objects in. We'll just go back to the class view. The next thing I want to do is now train that classifier. So I'm just setting up training a model here. It's going to be based on my object base, so the samples within my objects. I set up just a basic feature or feature space here. So you can see I've got the various mean layers selected, as well as some standard deviation and the NDVI and DWI. Okay, you put in more, and again, the type, I'm looking at a nearest neighbor classification here. I'll execute that. And one other thing, I mentioned that you can drag and drop features now from my feature view. I can just demonstrate that here quickly. So if I open up the list here, I can either bring in individuals, so I'll just take NDVI, for example, drag it down into the object information window, and you'll see it gets added here. Oh, you say, oh, what's wrong? There's just no image object selected. So once I select an image object, obviously we'll display the values for that. You can also do it for an entire group. Just bring them down in here, and you'll see you have then the values for all the different features in that, say, the parent grouping. All right. Great, so we have trained our classifier. We have not yet classified, so the next step is obviously to apply. We're just going to then apply this KNN classification to our image, and we will get our classification. All right. And if Christian, again, if questions come up while I'm doing the work here, then feel free to interrupt, and we can cover those.
All right.
So here I have my classification. We will I can just turn off the outline. So again, if you want to change your visualization of the image objects, just use it here up in the view settings, turn off the outline. Now I have the filled image objects. If you wanted to say, oh, I want to go back and see those sample objects again, just go into that drop down, select samples, or again, the class_color. And if you were working with a feature view, some type of displaying a feature, you have the feature value available in the dropdown as well. Okay. Excellent. So now I have my classification. I'm done with my NDVI and NDWI layers, since I use those as potential for the training of my model. I don't need them anymore, so I'm going to delete them from my project. Save on a bit of space. And now we get down to this part on accuracy assessment. So this is what I was talking about. We introduced several algorithms. We tried to keep it as simple as possible that will allow you to automatically calculate accuracy assessment. Right now, I'm executing algorithm for algorithm just to show you the different steps, but this would flow completely automatically from the top if I were to execute it. Just for demonstration, I'm going to copy this into a new level. It's not a requirement for the analysis, but I'm going to create a level called accuracy. One thing that we have slightly new is that your sample objects are now locked to your image object level. So I can keep my my training samples in the level training, and I can create new samples for accuracy in the level that I'm calling accuracy here. And that's what I will do. You'll see in just a moment. So now I've just created a second level. You see it come in here. I'm going to turn off the level called training. It's just a copy, so everything is exactly the same. I have my classified image objects, just in a image object level or an object level called accuracy. The next thing I want to do here is I'm going to delete my training objects. You see, when I copied the image object level, of course, since we're copying everything in that level, I now have almost double the initial objects that I had before. So if you were watching these sample numbers, you'll see, oh, all of a sudden my samples doubled. I'm displaying it here with some of these sample features. So you have features for the number of samples per class. That's what I'm displaying here. And we've also adjusted the way this feature works in version 10.2 to account for the fact that you can have samples in multiple image object levels. So you'll see now I have this one sample, this feature called forest, all levels. Okay, so that looks through all levels in my project. Since I copied training and called the new level accuracy, I also copied those training samples, and now those exist in two levels. So I had 25 sample objects for forest. That's what I see here, because I can also visualize this feature just for that level. So that's, you see forest in brackets training. That means there were 25 samples for the forest class in my training image object level, and across all levels I have 50. Okay, so you see that gets multiplied here. So what I am doing now is simply going to delete the sample objects in my accuracy class, because the sample objects that are currently there represent training samples, and I want to use different samples for the validation. Okay, so I'm simply going to go in. The algorithm is delete samples. Just tell it which level to delete them from. And we've also tweaked this algorithm a bit. We're going to combine two different algorithms and made them into one now. For deleting samples, now it's possible within delete samples, you can select which samples you want to delete. By default, it will be set to all, and you can delete them all. Or you can choose to say, well, I just want to delete samples from the forest class, and those will be gone. Okay, so I have it set to all. Simply execute that, and you'll see now that forest at all levels and forest training, the number of samples is now the same because the samples only exist in the level called training. Okay, next algorithm is, again, using this convert thematic objects to samples. And now we get into a slightly different use case for this algorithm. So we're getting a number of uses out of this. I want to convert, my vector layer to sample objects. I'm going to put these, again, I need to specify what object level to put these in, so I'm going to put them in the accuracy. This time, the thematic layer that I want to draw my samples from is the ground truth layer. All right. Its attribute is called class name. All right. And the other piece we added to this algorithm, I didn't use it before because at that point it wasn't relevant, was we have an option here to match class names. What does that mean? And we'll just open up the dialog here that goes with it. It can happen that you have class names established in your project. So for example, here in my project, in my class hierarchy, I'm using forest, grassland, urban, and water. You can see that my input layer has slightly different class names. Now those class names could differ just purely based on I didn't capitalize water, or for example, it wasn't grassland, it was grass. But those differences in the class names are enough that they wouldn't be recognized when doing this, when bringing in those samples. Okay, the class names have to be the same between both data sets. So instead of making you go back outside of eCognition, adjust your vector layer to match your class hierarchy, or vice versa, adjust your class hierarchy to match your vector layer. We've allowed you can do this mapping directly within this attribute mapping directly within the algorithm. So you can see here, I'm saying that any sample called grass, that's going to match with my grassland class, or water with a lowercase w will be water with the uppercase W here. Okay, a nice powerful piece to have. Also very useful if your ground truth data is maybe coming from somewhere that speaks a different language than you. I remember back when I was working on a number of projects in Indonesia, and I was given a beautiful ground truth data set, but all the forest attributes were in I think it was Indonesian dialect, and we had to go back and use the old translator to fix all that up. Now, very easy to keep the originals here. This is a point data set, so it won't have the overlap that we have to contend with. So we'll just execute this now, and we'll create now these new sample objects for our ground truth class. All right. And I'm going to come back in, and I'll just display. I want to see where those samples are. You'll notice that these sample objects are different than the ones that I had used for training. That's the way it should be. And we will come back and go back to our class color, but the samples are there, all good. And the next step that I want to run here is we have another two algorithms. This one is maybe optional, but it also has some nice use cases attached to it. We have an algorithm called compute accuracy values. All right. And this will allow you to compute automatically the kappa coefficient and the overall accuracy values within your project, and those will be stored as variables. All right, so I'm just running this. I'm telling it it's to run on the image object level, so it'll take from the class accuracy. and which classes to compute this on. And where are my ground truth? Well, there they are now, a sample class, and I'll run this on and to create a kappa. I'm just calling that the variable is this. This is the name of the variable I'm going to be saving this into is CK1 and OA1 here. Okay. Should run. Yes, it did. And now you see that I'm displaying these two variables in my object information dialog down here. So if the screen is small, that the kappa coefficient or kappa is at 0.93, so 93.3% overall accuracy. Here is at 95%. Why is this nice to have as a variable, you might ask? Excellent question. Well, it can tie into the level of automation you want. With this as a variable, we could then all of a sudden start using some if-then-else clauses within our rule set and say, well, if my accuracy coming directly out of the supervised classification is lower than, I don't know, 75%, go back and grow my training data set by 10% or 10,000 samples or something like that. You could also tie it into deep learning workflows to say, well, then I need to, if it's lower than 75, go back, adjust certain parameters automatically that you're using to train your deep learning model until this percentage is above whatever your goal value might be. All right. Finally, we have an algorithm here called export confusion matrix. What does it do? Well, pretty self-explanatory in this case. We can calculate your confusion matrix within eCognition, and we will also export it so you don't have to do this type of work outside the software anymore. So that's a very nice thing to have. It will simply write this out as a I believe a text file or CSV format. You can then open that in Excel and go beyond with it. Again, we're just saying it's image object level from accuracy. I've got my class filter set to forest, grassland, urban, and water. Those are the classes I want to see here. Have that also set here, that these are the classes I want to calculate that for. I'm using my ground truth data. Again, this is coming from that sample class. So I created samples for that. Alternatively, we can store that information in an object variable. So those are your options to either draw the ground truth information from your sample objects or from an object variable. You have the option to add what we call detailed statistics here. So when we export that file, you can get more detail. So you can include in the confusion matrix or below the confusion matrix, you'll have all the producer users accuracies calculated. You'll have your kappa coefficient overall, and a few other measures of accuracy will all be automatically calculated for you. Additionally, if you're going to run this this accuracy across multiple projects in a workspace. So if you're working in tiles, you want to make sure that each tile meets a certain accuracy. You can obviously do that. Each tile would have its own project, like I'm showing here. But you wanted to also make sure that for the entire project area that maybe was in 100 different tiles, you want to compute the accuracy of the entire project. You have the option to calculate what we call a flattened confusion matrix. So in this regard, what we're going to export is we're going to flatten those accuracy values into, say, one row from within Excel, and that would be for each project, and then your values would be computed across those different rows for you. Okay, so I'm using a single project here. I'm not going to choose the flattened confusion matrix option. Execute this, and rather than open it in Excel, I will show you what this looks like now within eCognition, because we also added a nice tool to visualize here. So under Tools, that's the Tools menu, you can go into Accuracy Assessment, open this Tools tool up, and you'll see you have different options to calculate your confusion matrix here based on samples. It could be a file flattened or on the object variable. Mine are in samples in this case. I'm drawing those from the accuracy level, and I want to calculate it for these different classes. So you could select classes if you only wanted to limit that to a few, and we'll show the statistics here. Get this out, and this is what I have for the confusion matrix displayed directly within eCognition. Okay, and we can see that we have this sort of heat map visualization here of the confusion matrix. We also have my statistics, not only, like I said, your producer, your user, but these are also the other statistics that we can export at the moment with the detailed statistics. So the Helden measure, short, again, our kappa, and then we also have the kappa and the overall reflected down here. So this is the kappa per class, I should mention. And then we have the overall and kappa values at the bottom here. All right, so this would be the same results that are exported, for example, as a CSV file, only here I have the nice visualization within eCognition. Any questions, Christian, that came up on accuracy assessment here?
Yeah, there's one question what you not covered, because you covered already a lot of questions which pops up, like users input, users accuracy and things like that. But there's one question quite interesting. Is it possible to use a point cloud as input for samples, like a labeled point cloud, to use this as a sample for classification in general?
Yes, you could. I'm just trying to think on my toes how I would do that immediately within the software, but yes. So if you had a classified point cloud, of course, you could take the classification field of those points. You would rasterize it. You could rasterize it. I think on that field, or we could read that field for an image object. What maybe the majority of points in a certain image object belong to the class tree. So that object would be called tree, for example. And then you could take those. You could use them as samples in various methods within eCognition. Yeah.
Yeah, perfect, Keith. That was also what I'm thinking, that the point cloud attributes are available, as object attributes, so that we can use also this information to select samples and also to check the accuracy of the classification. That's
right.
The cool
so here you have
of the data fusion. Yeah.
So right here we see for image objects you have point cloud, and here you see the different fields that we support from point clouds. One being the classification field. So you could read that.
And then there's also some feedback that some algorithm or some values like kappa is not longer a recommended accuracy assessment matrix, and that's a recommendation that we should think about this. And I would highlight here to open the community to discuss this, which accuracy matrix makes sense here.
Yeah, like I said, if you have a specific wish to add on to, it's easy to add different measures of accuracy within the software. So if you have a specific one that's not done here, then just add it to the wish list, and we'll get it in the next go round.
Then there's a question that if the attribute mapping from a thematic layer, it will be also available for the assign class by thematic value algorithm. That's interesting, this question, because I think we should discuss this separately, but it seems to be a very interesting question from a user here in Germany. That's
could be a very good idea. There's some workarounds that I have off the top of my head, but yeah, that's something we could definitely discuss further. Yeah.
Okay. That's, well, currently the question concerning the accuracy assessment. I have also some other questions, but we should discuss this after.
Yep, we can get to them. I've just got a few more things to show here. So next demonstration that I had up, this is a much easier one, or a simpler one, is the native, the deep learning based point cloud classification. The algorithm is really actually called automatic deep learning based point cloud classification. And I have two different examples that I've pre-run just because it takes a little bit longer. This, first of all, this is a large point cloud, and a deep learning is a little bit more processing intensive. So I have two different point clouds. One is obviously here aerial LiDAR. The other one is terrestrial LiDAR, and I'll show you just the two different modes and what the results look like. So again, this algorithm is available in 10.2. It's flagged as prototype because we're still working on our deep learning models in the background, but let's just put it this way, we were comfortable enough with those deep learning models that we said, hey, people can make good use out of them, but just take it for granted or take note that this is a prototype, so it may not be 100% at the moment. When you have this algorithm open, very easy to set up. You have an input layer, obviously here, I haven't renamed input layer 1, that's my LiDAR layer. And you have two different models that you can apply here, or I should say 3. This is one of these is an internal model. Because I work for Trimble, I have access to a little bit more behind the scenes, but you have two models available to you. One is going to be called aerial and the other one terrestrial. So if you have aerial LiDAR, obviously you want to select the aerial model. And at the moment, we are supporting these classes that you see down here. So ground, medium, vegetation, and building. And our plan is to build that out over time. You also see some advanced settings here that refer to batch size, tile step. You can adjust these if you like. Our recommendation at the moment is to keep the default settings. That's where we've had, I say, the greatest success at the moment. So I executed it in advance, and you can see now I'm on this point cloud tab in my process tree menu, and I'm looking at the height-based visualization at the moment, but I can change this now to the classification. Any of you that have driven through Vermont might recognize this scene. This is actually in Montpelier at our state capital, which is this dome, and I will point out it was incorrectly classified. And that just shows some areas of improvement within our model. So I'm going to zoom in and I'll point out some of the inconsistencies here. Right now, one weak spot is flat roofs. So you can see there are a number of flat buildings around this capital square, let's say, and there's some points that get misclassified as ground in there. Also a bit of vegetation on the Capitol dome area here. All right. Those are areas, like I said, our deep learning model, we're constantly training behind the scenes. So we hope by the next release that will be greatly improved. But given past automatic classifier results that we had available to us within eCognition, there are some nice improvements here. I've used it in a number of forestry applications and was very pleased with the much cleaner results. We're really getting a good discrimination between trees or high vegetation in building. All right, so that is some one area where we've done this, applied this model. Again, you can see here, once we start getting into more non-flat roofs, it does improve a bit. Okay. The other example I have, this is now a terrestrial point cloud. Off the top of my head, I can't remember what device. It could be based on maybe the number of scan points. It might be an SX12 or an X7 both triple devices. The only difference here is that with terrestrial, so obviously I've chosen the terrestrial model. I also have a few more class options for terrestrial here than I had for aerial. So I have a difference between low and high vegetation. And we should also see, so this is my classification result here. If I come in and just change my views, and we'll come in, we can actually take a 3D sample here just to see how this worked. Here's an area with a building, a wall, some vegetation, and we can see very nicely how our vegetation, you can see here, I have to see it, I'm not sure if that's a flagpole or just could be a piece of a tree over there, it could be a flagpole. But where we have a much improvement is particularly on building facades, and you'll have to take my word for it when comparing it to our old automatic classifier. A number of these sides of buildings or trees were mistakenly classified as buildings. So we're seeing great improvements here in terrestrial point cloud classification as well. And again, a prototype algorithm. Don't be afraid to experiment with it. You might find, like I said, in a forestry environment, I've been having great success with this, and you may also find great places to use it, and we'll be improving the models as we advance here with eCognition and in the next releases. Okay, great. So I will jump back into the presentation at this point and start to wrap up our show for today. Those are the demo projects. Again, we can field some questions as we go on. I just want to point out, again, we not only work on our software during release phases, but we also are constantly working on the eCognition resources that go along with the software. Learning never stops, and that's definitely true for eCognition. So a little update for eCognition TV. Again, that's our YouTube channel. If people really liked what they saw in the accuracy assessment demo that I gave here, go to the YouTube channel, go to eCognition TV. Our Matthias Stengel has really done an incredible job looking at the accuracy assessment algorithms and tools in depth there. He also covers how that works in a workspace environment, so using those flattened confusion metrics tools that are in the software. So go check out that video. It's available now. It came out with the release. In addition, we also have some great eCognition deconstructed videos planned and that are coming soon. And these will also look at some of the new functionality we added for deep learning. So supporting those third-party models. We're going to have coming soon where you'll see how to load external model. We're also going to look at the apply instance segmentation algorithm. And then we have some other videos that will be coming to you in the near future for the delete layer algorithm, morphology. I'm looking forward to that one. That's a great algorithm, as well as update array. So again, for that, subscribe to eCognition TV. Get the update on your smartphone as soon as a video is there. And the team really does a great job with this material. Beyond that, again, always adding on here. So go to that community. Some people had some good wish list like items that they mentioned today. Use that the community discussion forums material there. You'll get tutorials. Normally for those deconstructed videos, you can access the data behind it through the community. So check that out. Social media, we have our eCognition group in LinkedIn. Keep up to date on all our tips and tricks and things of that nature. Already mentioned it enough, eCognition TV, YouTube. Just tune in and learn how to use these algorithms or workflows in a great way there. We always have our support. The blog, always getting new blog posts out. I have one in the works. Let's see if I get to it here before the holidays or not. But I do have one planned at least for December. Maybe it'll be early January when I get to it. And of course, our documentation, either within the PDFs or online. And yeah, webinars and training. As we come out of the slump of COVID, we are starting to get back out there doing trainings, if not in person. We also have a number of online courses, some paid for, and a number of them, the majority, are free, that you can go in and correspond to a lot of the deconstructed videos that we do. And this will be my last plug for the community, is again, and Christian, he really pointed out a few great wish list items, comments, suggestions from you during the webinar today. Please use the software wish list in our community. We go there quite often. You can vote for wishes that people make, and really we do look at those votes. So if something gets a lot of votes, it's an indication that a lot of people want it, and that pushes it up its priority level in development for us. So go there, make your wishes, get voting for other people's stuff that you like on the ideas, and stay tuned. Any other questions now for question and answer, Christian? I think we have a few more minutes.
That's great, Keith. And it is fantastic that you highlight here the eCognition wish list, because there are already some wishes here in the discussion group or in the question group. For instance, there's one user that had some issues with the license server and would love to see an eCognition licensing in the cloud. That's quite interesting. Mm-hmm. Well, please insert this into the software wish list. And also people who have issues with the licensing, also please contact the support team so that we can learn what we can improve with our local licensing approaches. But that's the idea of the wish list, to share your needs, that we are informed. Okay, Keith, there were several questions. If it's possible to use point cloud data in eCognition. You mentioned this already in your presentation at the beginning, and you showed some examples. And at the end, you say, hey, in the eCognition community or in the knowledge base, there are a lot of examples, project examples, and tutorials available to use and classify point cloud data. And I would say, before we go here in all the different questions, like for instance, is it possible to classify trees on point cloud data coming from LiDAR? Yes, it's possible. And there are examples available in the eCognition knowledge base in the library. And please use our support portal here, search for it, and you will find a lot of material resourcing to learn, to see how it works, and how it works in eCognition, especially to load, to visualize, to analyze point cloud data in general. Then there was also a group of questions if point cloud data coming from photogrammetry approaches, from UAV data, if they can be also used as input for a classification. Yes, the same procedure. To load and visualize those data, but also for classification. That's in general, Keith, here to summarize this. But you mentioned this already, and would like to highlight here also the eCognition community. If you have questions, use the community, ask other users, and also we from Trimble are active here to help you. Okay.
Yeah, and also search the community. If you there's a great deal of material that's already there, and the search function that we have will, based on what you type in, will try and give you the best recommendation for that, and so you may get an answer to your question without actually posing it. So please make use of that.
Cool. But there are 2 point cloud questions what I would like to ask here. What do you think? It's a tricky question. The first one is it possible to extract vector layers, a polyline, from a point cloud classification? What do you think?
Yes, absolutely. So if there's actually a good example in the eCognition community where we're classifying individual trees in point clouds and extracting a number of different vector layers for those trees. So one of them is a polyline. We generated a vector line for sort of representing each tree stem or each tree trunk. And that can certainly be done. They're 3D vectors, you can export them, you can visualize them in eCognition in, say, 3D or 2.5D. So yes, it is possible. Kind of, I guess if we get back to the famous eCognition word, it depends. So if that's the type of line you're looking for.
Cool. And the last question is really, really interesting. Is it possible to load the point cloud data coming from a laser scanning inside the building to classify the furniture, or more or less to remove the furniture, and so that have just the empty rooms available in the point cloud? What do you think? I have no clue.
Okay, to load it, again, if it's in LAS or LAZ format, you can load that into eCognition. Yeah, try to classify. So obviously you can see from our pre-trained deep learning based classification models for point clouds, we don't include office furniture or indoor classes yet. So there you would have to fall back to some of the more of the traditional OBIA tools to start describing the objects. Say maybe we can describe it as interior noise points that you'd want removed from your model. Maybe one recommendation would be to try the automated classifier, see how that gets. Maybe that I would assume that would be good to get your walls. And we start from there and try and describe maybe other freestanding furniture using some of the other tools. But we don't have any specific tools to maybe approach sort of these BIM topics yet.
Keith, thank you very much. That were all questions from the list.
Great, excellent. Then at this point, we can start closing things down. I'd like to say thank you for your attention, your questions, and we'll leave you here. This is a little GIF that we made in Bordeaux, analyzing mobile mapping imagery coming from the Trimble MX9 using one of our a pre-trained deep learning model with the new instance segmentation or apply instance segmentation algorithm within eCognition. So it not only supports aerial imagery, but also mobile mapping imagery. And that being said, yeah, thank you again, and we will see you next time. We'll celebrate a great holiday season. Again, thank you for all your time. Use the community to make those feedback and wish list items to us, and we'll do our best to get them in the next version of eCognition. Have a great rest of your day, and take care.